the bright side and pretend it's a golf score. Okay, I'm going to talk a little bit about LISP. For those of you planning to sleep through yet another introductory tutorial type session on LISP, you're going to be disappointed because I have only about 4 review slides on what LISP itself is. I'm going to actually talk mostly about some new technology that we've developed to make LISP easier to deploy at the sites, a briefing on what's going on in the IETF, and then some probably familiar stuff about what's going on with the implementation and deployment. There's a little bit of change there. The most interesting development there, I'll give away the secret now, is that there really is work happening in iOS for LISP implementation. And then I'll have the usual spec references with a slight twist, and then some Q&A. So as you can see on the title slide, this is actually the work of a bunch of different people, 2 of whom are also here, namely Andrew Parton is here and Dave Meyer is here. I guess I was picked to come and give this presentation because of a burning desire to see Philadelphia and to visit East Coast weather where you can get a workout in and a shower all at the same time, as I discovered during the hailstorm yesterday. That was kind of fun. Being in Northern California, the weather is really boring in the summer, so this is actually kind of an exciting change. Anyway, so getting back to a little bit of history, as I said, there are going to be about 4 briefing review slides. What provoked this whole LISP effort? Basically, there was a workshop held back in October of 2006, sponsored by the IAB. A bunch of people got together who were concerned about scaling of the internet, in particular scaling of the internet routing system. And that's kind of what originally motivated us to put the LISP stuff together. It actually came up during a dinner conversation that we had back in October, and it's since then kind of proceeded in fits and starts through various working groups, various IETF working groups, various operations groups, the usual NANOG, Apricot, right, et cetera, and is now actually maybe seeing some of the light of day at some point in the not too distant future. Again, it was motivated by a desire to scale the routing system. This is a picture that everyone's probably seen 1,000 times by now. Actually, brief survey. Who here has seen a LISP presentation before? I expect to see just about every hand in the room go up. Okay, good. That means the review can be very short. But anyway, as I said, it was motivated originally by this graph. Growth of the routing state. It's up and to the right. It's obviously not linear. It's somewhere between quadratic and exponential, we think, according to Jeff Houston's curve fitting. And it continues to proceed despite the global economic meltdown. One of the interesting things about the pattern on this graph is that if you look at the period between 2001 and 2002, there's a clear flattening. That was the bursting of the internet bubble. We don't see a similar flattening up in the upper right-hand corner of this slide, even though the economic decline is much more pronounced than it was back then. That's interesting. I don't know if it's something to be worried about or if it just reflects a different sort of economic slowdown that predominantly affected the internet in 01, 02, but it is affecting everything now. One comment on the upper right-hand corner, you see a spike there, an apparent decline, and then a resumption of the curve. That's actually not a decline. That's a change in the data collection. I guess Jeff lost one of his BGP feeds, so a bunch of more specific routes that were contributing to his count went away. The curve has continued using pretty much the same pattern. As the saying goes, I have some good news and some bad news. The good news is, and this is going to plug a URL that I guess is visible more on there than it is on here, of a slide presentation that Jeff is planning to give at some point in time that actually suggests that stability of the BGP in the global routing system has actually improved over the past year, which is something of a surprise. It suggests that maybe we don't have to worry quite as much about the rate of change causing problems with CPU utilization, memory speed, et cetera. As the saying goes, we're not that sure of our facts, to quote Mr. Spock from a famous Star Trek episode. But so, the bad news is the trend is still up and to the right. We're not that sure about the data. Multi-home, in particular, multi-homing is still hard. And one of the nice things about LISP is it actually makes the multi-homing problem easier to solve, not only for the global routing system, but also for sites. It actually gives you some traffic engineering and some other kind of site pairwise source to destination site optimizations that you can do that you really can't do with the global routing system and sending more specifics. Dave, did you have a question or a comment? You look like you stood up for a second. No? Was it something good? Go. Okay. So what is LISP? Basically, it stands for Locator ID Separation Protocol. It's a way of taking the internet address space and creating two numbering spaces out of it. One is a set of endpoint identifiers, EIDs for short, that are assigned to hosts. They're not routed on the global routing system, so they don't contribute to the routing system growth. The other are a set of routing locators, or RLOCs, that are topologically assigned. For most practical purposes, that means provider assigned, and they're used for the actual global routing system, the BGP, between providers. What that separation allows us to do is it allows a couple things. It allows, first of all, it means that we can actually use both topologically significant numbering for the routing system, which is the best way, in fact, the only way we know to make it scale. But we can also have topologically independent assigned numbering for the sites, which allows you to have things like provider portability, avoidance of renumbering, et cetera. When we came up with LISP, there were a bunch of kind of rules that we set for ourselves. Not surprisingly, since most of the authors are from Cisco, it's a network-based solution rather than a host-based solution. We don't want, but that actually was more driven by the second bullet, which is we don't want to have to change the installed base of hosts. And there are a lot more hosts out there than there are core routers, and in fact, a lot more hosts than there are endpoints, end site routers. No addressing changes, again, for things within a site. Minimal configuration change, even to things that have to change. And it has to be incrementally deployable. As Tony Lee said during, I think, an RRG meeting a couple years ago, deployment wins. If you can't deploy something, there's really no point in designing it. And it's address family agnostic. In other words, it works for IPv4 and IPv6 and various combinations of the above. So this slide, and a little plug for Dino, all of the non-boring, or less boring, I should say, slides that have more than just text on them are done by Dino because he's our graphical wizard, in addition to being our implementer. But it looks like all of our animations are gone because we're using the PDF. Anyway, this is kind of a very brief overview of how LISP works. On the left side of the slide, you can see a source. Right side is a destination. Source wants to talk to the destination. It has an EID for a particular host within the destination, typically returned by the DNS. That's why you see the little DNS entry here. It looks just like an IP address, but it's not globally routed. To get from the source to the destination, since it's not globally routed, there needs to be some sort of it's not really a translation, it's an encapsulation that gives you a globally routable routing locator for that particular EID. The way that works is the source will send a packet. The source host sends a packet just as if it would send any other TCP open, UDP packet, whatever, to its exit router, which is a ITR or ingress tunnel router. The ITR will then encapsulate it with an outer header that is routable, and keeping the inner header that has the source EID to the destiny EID, and then an outer header that has a source locator going to a destination locator, which is globally routable. I'll talk in a minute about how it finds the appropriate mapping. It then sends that packet off into the internet towards whatever the routing destination is for the destination locator. In this case, since the source is connected to provider B, it's going to send it to provider B. Provider B will route it to provider X, since the destination RLOC is on provider X's topologically assigned network. It will get to the destination. The destination will look up the appropriate mapping, and then will send back the response to the source, which then can install an entry in its cache, and then can send packets from source to destination using an outer header with the source and destination locators added to the inner header that has the source and destination EIDs. That was a lot to say. And hopefully you've seen this, as I said, hopefully you've seen this sort of stuff before, so this is a review. If you are interested in more tutorial information, let me know. We have tons of presentations. I can point you to one of them. A couple things to note. Down at the bottom, the mapping entries have some simple policy that allows the destination to control which of its locators, in other words, which of its entry points from its providers to its site are used, and for what proportion of the traffic they should be used. The priorities control which are preferred absolutely over others, where the weight controls whether there should be some proportional load splitting across the different locators. Along with, as I said, in the previous slide, I would talk about how you find the appropriate ETR for a particular destination EID. Well, that's where this thing called LISP Alt comes in. Basically, what LISP Alt is it's an overlay network of tunnels. We spec out GRE tunnels in the RC or the draft. In fact, any tunneling technology can be used with BGP running over it, so that the EID prefixes are advertised on an alternate logical topology, that's what the alt stands for, of these tunnels, so that something connected to the alt virtual network can get to ETRs that are advertising the EIDs into the alt network. By doing so, they can get a map request from the source to the destination, which then can respond on the underlying internet with the appropriate locators. A couple different classes of alt devices. Could be an ETR and ITR that is connected using GRE and BGP, a map server, a map resolver. Those are the new technology that we're going to talk about in the next couple slides. Or it could be just an alt router, which is basically could be an off-the-shelf Linux system. Doesn't have to be a high-performance router, just running GRE and BGP to connect to this virtual overlay network. Here's again, no animations. Dino's going to be very disappointed that they didn't make it. But this is kind of graphically how you use alt to find the appropriate ETR. Basically, source has the source location, the source host has a EID that it's received from the DNS. It basically sends it off again to its exit router, which is a ITR. The ITR has, in the normal alt case, the ITR has a BGP connection and a GRE connection to the virtual network. It basically just routes on the destination EID, which puts the traffic onto the virtual network, routed across the virtual network to the appropriate ETR that originated an advertisement for that EID. The ETR can then look at the map request, look up the locators for the particular destination, and return a map reply. A couple things to note. If you look in the upper right-hand corner, you can see two examples of ETRs that are advertising BGP routes into the alternate topology. Then you can see an alt router that's aggregating them. The idea here is that the alt topology is a virtual topology, so we can basically dictate how it's connected. It's just tunnels. You can if you need to move from one point in the topology to another, you just change a tunnel. You don't have to change who you're actually connected to. So we think that the alt will be pretty well aggregated, and it doesn't have to be perfectly aggregated, but because we can control the topology, it can be. The other thing to note is the blue line at the bottom here. That's a map request. That's a map reply that's going back over the underlying technology, the underlying internet topology, basically from a locator to a locator. It doesn't have to go back over the alt virtual network. Only the requests go, the replies do not. So, LISP map server. Basically, it's the easy way to talk to alt. One of the complaints we got when we came out with the alt spec was, you guys are talking about doing, making multi-homing easier. Well, one of the hardest things about doing multi-homing, at least what we've heard from enterprise sites, is doing BGP. And, we've replaced regular BGP with alt BGP. Well, to a lot of people, that's just as difficult, just as much of a pain as regular BGP. So what map server does is it actually allows you to move the BGP function into the alt routers only, and just use analogously to map resolvers and map servers, or DNS servers and DNS resolvers. We have map servers and map resolvers, where basically an ITR just has to be configured to know where its map resolvers are, sends the request there. The resolver talks to the alt, routes the map request appropriately over the alt to other alt routers, to possibly a map server that is now advertising the EID prefix on behalf of its ETRs that also don't have to run BGP now. We use a IPsec authentication header at the edge for the communication from ETR to the map server, so that you don't have to have as much static configuration, and there is authentication. The ETR is still the source of truth for a particular EID mapping. It advertises it using this authenticated map register mechanism to a map server, which then is what propagates it out onto the alt. Again, ITRs only have to know about appropriate map resolvers, which, by the way, can be any cast, we'd expect, instead of having to do BGP and connect to the alt. One thing to note here that you'll see in the next slide is that the ITRs actually encapsulate the map requests that they originate inside of an additional LISP header, because the outer header needs to contain locators. In other words, the resolver destination IP addresses are globally routable locators, while the actual destination for the map request is an EID. So you need to be able to route that across possibly multiple internet hops using a globally routable locator before you can put it on the alt. We expect that most map server, map resolver functionality will be in existing alt routers, although you can certainly implement that using a separate box that implements both the map server, map resolver, and alt. Again, this is kind of the easy way. The other way is the hard way. The easy way, contrast. Here's where we show XTRs connecting using a map server and map resolver. On the right-hand side, we have ETRs that are connected, an ETR up in the upper right-hand corner that has registered with this alt router, which MS in it means map server. The map server is now responsible for propagating that EID into the alt instead of the ETR doing it itself. On the upper left-hand side, we have an ITR needs to send a request for a particular EID prefix. It's going to just send it to a nearby map resolver that it has configured. The map resolver now, and as we see in the upper top row here, we show the extra layer of encapsulation. ITR needs to look up a mapping for 240.111, creates a map request using itself as the source RLOC, destination EID, and then it puts an additional header on top of that so that it can route it to the map resolver, which may or may not be directly adjacent to it. And by the way, I'm going pretty quickly. All this stuff, I think, is reasonably well described in the appropriate internet drafts, which will be referenced at the end. Now, the map resolver, what it's going to do is it actually will strip off the outer header, since it is the destination. It will then take the original map request that was generated, forward it across the alt to a map server, which will then put another header back on it because it needs to route to the destination ETR, which is not connected to the alt and therefore cannot use the EID prefixes as destinations. Then, just as with any other map request processing, the ETR looks up the destination EID and returns the appropriate map reply with the locators across the underlying internet topology without going through the alt or through the map server or map resolver. This is kind of another view of the same example that's showing kind of the detail of the extra layer encapsulation. Again, the ITR wants to look up a particular destination 240.111. It's going to create a map request, send it to one of its map resolvers. In this example, 1111 to 65.111. Again, these are globally routable regular internet IP addresses. Map resolver will take off that layer of encapsulation, route it across the alt, which could be any number of intermediate alt routers, to a map server. Map server then puts another header on it, still the same map request, but it needs to get it to the ETR, so it needs to put RLOCs on the outer header, sends it to the ETR. The ETR then returns the appropriate reply directly from ETR to ITR. Just one quick slide again. For an ETR to advertise a particular EID prefix into the alt, since it's no longer connected to the alt, it now has to do a LISP map register, which has an authentication header on it, sends to one of its to all of its configured map servers, saying, I'm the source of information for this particular EID prefix. Here's my locator set. The map server then takes that and advertises it into BGP onto the alt, which then propagates to the other alt routers and is therefore available for map resolvers to use. Again, both map server and map resolver are running BGP and GRE, while the ITRs and ETRs are not. The trade-off here is that more work for the people administering map resolvers, map servers, and the alt, but they're being paid to do that. less work for the site administrators who have other jobs like running their site. One thing to note is this interoperates with traditional ETRs and ITRs that are running alt. Basically, the map resolver, the maps resolver, and map server are just participating in the alt, just like any other device. So, as far as the traditional alt-connected ETRs and ITRs are concerned, there is no difference. This is one final slide on map server that kind of shows Dino's concept of several different layers of edge XTRs, kind of an intermediate layer of map servers and map resolvers to provide a interface, a simplified interface to the alt core. Okay, switching gears a little bit. That's the new technology part of the presentation. I want to talk a little bit about where LISP is going in the IETF. LISP actually has a pretty long history, pretty much almost from the beginning with the IETF. As I said, it was invented during a dinner conversation at the Routing and Addressing Workshop, IAB-sponsored Routing and Addressing Workshop back in October of 2006. We started then talking about it at the following November 2006 IETF in San Diego. We had presentations at pretty much every IETF, either in the RRG, one of the working groups, the GROW working group, internet area, routing area, et cetera, in 2007, 2008. There was a experimental LISP BOF in Dublin back in July of 2008. It's not clear whether this was an experiment with the BOF process or whether it was an experiment talking about LISP, but it was not exactly a success. There was a lot of confusion, and we're not really sure what came out of it. Meanwhile, there's been a lot of discussion on various mailing lists, in particular the RRG list, created some LISP lists, et cetera. And there actually was a real LISP BOF chartered at the IETF in San Francisco back in March. And at that point, we had kind of a review of all the LISP internet drafts, discussion about whether to go forward with a working group, and as a result, a working group has been created that will meet for the first time in July at the Stockholm IETF. Darrell Lewis, one of the LISP co-conspirators, is a co-chair, and Sam Hartman, who has a long history with the IETF working as a co-chair and in other aspects of the IETF process, is the other co-chair. In the last month, the core LISP documents have all been renamed as working group documents, and there are a couple of new drafts that have come out independent of the core LISP team that discuss other attributes of LISP and other ways to be used, other mapping database proposals, et cetera. It's actually a pretty exciting time, and we expect some lively discussion at the Stockholm IETF. Quick review of the implementation status. The original implementation is under Cisco NXOS, which is kind of the data center product operating system. It's originally Linux-based with a whole bunch of other stuff on top of it. Our test platform is a thing we call a Titanium. It's basically a PC with a bunch of gigabit Ethernets. The implementation includes LISP, alt, interworking, map server, map resolver, and this thing we call LIG for taking a page from the definition of ping. It's the LISP Internet Groper diagnostic tool for actually testing the mapping lookups. Today it's software switching only. It does support IPv4 and IPv6, as both the underlying and the overlaying protocols in any combination. There's ITR, ETR, and PTR implementations, and there's LISP-NAT for IPv4 only. There is really iOS implementation in the works. I don't have any dates or trained information or anything of that sort, but it is being worked on. The initial target is expected to be ETR-type devices that will implement the LOC-ID split functionality. There is some thought about doing an XR implementation for implementing traffic engineering, ITRs, and ETRs kind of within the network. That talk is currently preliminary. There has been an OpenLISP implementation for FreeBSD out there for a while. Currently testing the specs and working on interoperability. We've heard that someone has been working on a native Linux implementation, and that's something that we'd be really interested in and would like to see more of. If there are any other efforts we don't know about, we'd love to hear it. The pilot network, I'm going to skip right through this because I'm out of time, uses the titanium platform. We use a couple of different prefixes. One thing to note is the GRE tunnels that make up the alt infrastructure are using 240/4. For those who say that you can't use 240/4, well, you can in some cases. And we're using 32-bit ASNs to try to push the state of the art. This is a kind of a map, an overview of the pilot network topology. It's about 30 or so sites. There's kind of a core that represents geographical distribution in the middle. There's the Europe region, there's an Americas region, there's a South America region, and there's an Asia-Pac region with the different sites logically connected via alt to those core sites. Deployment, we do have interworking deployed. There are actually two different mechanisms of interworking. There's one based on what we call a proxy tunnel router, which is a device that implements LISP on the inside, but also advertises coarse-grained information of EID prefixes into the global routing system. And then there is also a LISP NAT implementation. Both of those are documented in the interworking document. We have both of them running kind of in a pilot mode. And as you can see from these URLs, there actually are ways to reach and use both of them. As I said earlier, or as I implied earlier by all the IETF effort, this is something that we've been trying to get out into the community since the beginning. It's an open effort. It's not a Cisco effort. There's no IPR on this stuff. All the documents are internet drafts. All are intended to go through the standards process. And we are actively seeking other implementations and other implementers, designers, testers, etc. If you're interested, please let us know. And if you are actually from one of the LISP beta sites and you're here, and I haven't met you, I would actually love to meet you in person on a personal note, so please come and find me at some point. Here's the list of internet drafts. As you can see, the 5 core documents have all been renamed as working group documents. There are also several other drafts that discuss implications of LISP that aren't necessarily protocol documents or are work in preliminary progress. The documents circled in red down at the bottom are all either researchy documents or are things that we're not currently pursuing. And that's basically it. Here are the references, public mailing list for the IETF LISP working group. There's the contact information for the core LISP team. And there's lots more information, including tutorial presentations, et cetera, at the lisp4.net and lisp6.net websites. And that's all I have. So if there are any questions or comments before we break for the break, this is a good time to offer them. Don't want to keep anyone between here and coffee and snacks. So hopefully this will be quick. Dave.
Vince, I just want to say that there is a Linux implementation. It hasn't been released yet. It's been written by these guys, Roque Galliano and a few others of his friends down in Uruguay. Right. And they expect to release that. I talked to them at the LACNIC meeting a couple weeks ago about this, and they expect to release their code this month.
Okay. Do you know offhand if theirs is based on OpenLisp or is it entirely independent?
It's entirely independent.
Okay, that's interesting.
It actually runs on either Linux or NS3.
Oh, cool. Oh, one comment kind of referring to the last presentation. We hope that this will not be an overnight success that takes 7 to 10 years also. I guess, Jari, I think you're next.
Yeah, so Jari Arko Eriksson. So I had a little bit of additional information about the IETF stuff and then a couple of requests. So the additional information is that we've been getting a lot of proposals in this space on the routing scalability, multi-homing, and so forth recently, and we are considering other approaches as well. So for the Stockholm IETF, which is coming up in a month, we actually are talking about something called a multipath TCP, which is basically something that looks like a regular TCP for applications, but it's actually multiple TCP sessions between address pairs on the wire. And this is a slightly different trade-off of a solution than LISP, but it basically allows you to pump more data through than you would be able to do with a single TCP session if you had multiple interfaces. So that's one thing that is possibly happening. And the request part is that if you care about this space, please come to the LISP working group, come to the multipath TCP BOF, come to the RRG. The meetings are at the end of July in Stockholm. And also, it would be really cool if they could test some of this stuff, not just LISP, but also the other things. And both LISP and the multipath TCP are targeting experimental specifications, which means we're not quite sure that they are ready for real-life wide deployment. We know that they have problems, and they probably have unknown problems as well. But it would be really good to look at this stuff on a little smaller scale and find out how well it works or doesn't work. So please consider that.
Yeah, just to emphasize, LISP is certainly not the only work in this space. We think it's probably the farthest along, just because we've been working on it for so long. But there are a lot of questions that are still unanswered. And the LISP working group itself has a pretty restricted charter, but there will be a lot more discussion of other solutions at the next ITF.
Right. There's plenty of solutions in the RRG space, but only 2 are right now being discussed in the ITF, and then we had the old solution, SIMSEX, which is a working group that just completed its work.
Right. Next, at the front mic. I think you're up next. Yep.
Sriram from NIST. Vince, can you go to slide 13, please?
13. Okay.
So previously, there was a lot of discussion about the first packet delay and loss. With your map servers and map resolvers, is there something here that cuts down on the first packet delay, the response to the map request?
There's nothing that directly cuts down on the first packet delay. We are looking, this is actually a little bit beyond the scope of this presentation, but one of the things we are looking at is mechanisms for doing caching at the resolver, which would eliminate the delay for all of the clients of a particular resolver that need to talk to any of the sites that have been contacted by another one. And one of the things to note is that unlike a DNS or an ARP cache entry, the cache entries for the EID to our locator mapping are basically entire sites. So the first time anybody behind a particular resolver contacts Google, anybody else that's using that resolver would not suffer the first packet delay. But no, we're not looking at holding packets or trying to propagate them. The alt spec does talk about the concept of a data probe where you can actually forward the initial packet across the alt. That's something that we can certainly consider if the first packet delay is a major issue. But we think that just has some really bad scalability properties. But as I said, we're looking at adding more caching at the edge at the map resolver to deal with that. As for DOS attacks, well, the existence of the map resolver in effect protects all the alt routers from DOS attacks, because since the ITRs don't have direct access to the alt routers, they don't have any routes. They're not part of the alternative topology. There's no real way to get the DOS packets into the alt system. The other thing is that just like DNS resolvers, map resolvers can be anycast, so that gives you a way to spread out a DOS attack among multiple targets and reduce the severity of it. That's a good question. It actually is something that would be worth discussing on the LISP mailing list.
If you're doing caching, that's great. That's what I was trying to.
We're not doing it right now, but with something we're looking at. The initial spec, because we're trying to keep it very simple, does not call for caching, because there are some differences in if you implement caching, then you have to change the request response dynamics so that the resolver, instead of simply forwarding the request, it actually has to carry state for every request so that it can receive the replies and cache them. We've got some ideas on how to do that. The map server, map resolver spec does allude to that, but we're not implementing that on day one because we want to experiment with small steps before we take big steps. But it's certainly on the table. Back mic.
Sandra Murphy, Sparta, doing business as Cobham Analytics Solutions. Sorry about that. You may have heard me say words yesterday about origin authentication, and BGP was an absolutely necessary, and we had to do it first step for everything. So slide 10, please. So I see ETRs registering site EID prefixes with only a pairwise trust model, and maybe having eaten the green berries on one bush and making a really bad stomachache makes me leery of all berries on all bushes, but that sure sounds like origin, authentication, validation necessary being
My
added
answer is
to
gonna-
yet another protocol.
Right.
And I'm more than a decade from retirement. Maybe this is just good fodder for interesting stuff to work on for,
Okay.
but,
Well,
you know,
let me refer back actually to the original alt spec on that, because basically the authentication because we're using BGP, we basically on the alt will be able to take advantage of whatever BGP authentication mechanism is created for origination at the point where a map server receives the request from a map resolver. I mean, from an ETR. We're not trying to solve that problem on our own, because there's been tens of years of work already on things like SBGP, SOBGP, et cetera, and the whole CIDR trust model for the certificate delegation, all that stuff. That's all equally applicable to alt BGP as it is to global BGP.
okay, so when the map server starts advertising the prefix,
Yep.
they're going to be doing it in BGP announcements with the same sort of origin authentication, so the CIDR work applies.
On the alt, correct. And,
Okay.
and the authentication header between the ETR and the map server is a pairwise
Right.
thing that is
Just
established
like
out of
in
band between
yeah.
the administrators.
Okay, thank you.
Is that good? Is that your answer? Is that what you're looking for?
I sure hope so.
Okay,
Thank
great.
you.
Two more questions, and then we are way over time, so we're going to quit after that. Yes.
Dave Crocker, given how long locator ID stuff has been chatted about with a desire to pursue it, it's really nice to see this kind of progress on something pragmatic.
Well, thank you. It's something that's been talked about since the 1960s, actually. More recently, in about 20 years ago, when the whole IPNG effort was getting along, Noel Chiappa talked about it. The people that invented IPv6 kind of totally missed the boat on this, and now we've decided that, well, this is something that's really fundamental that we have to now retrofit in, and that's what we're trying to do. But continue.
Yeah, V6 largely dodged the question of being creative with addressing, and the stuff back 20 years ago that was frustrating was there were ideas, but there weren't details, and you can't
Right.
really make decisions without the details.
Right. And one interesting thing to note, of course, is that one of our co-authors is Noel
Yeah.
Chiappa, who's been a great proponent of this over the years.
Did notice that.
Yes.
In looking over some of the documents, they're all appropriately technical and focus on the how. And what I didn't come across, and what might actually help the recruitment effort and later the adoption effort, is something which is essentially a non-technical document that talks about value proposition and cost benefit, where the cost part is designed to address people's fears. So, for example, the use of DNS for lookups with packet handling was a huge fear in the discussion 20 years ago.
Right.
And you've overcome that, but you're going to run into all sorts of resistance because it's a deep psychological point.
Right. We're already seeing that on various mailing lists.
Sure. But a fairly brief discussion which says, here are the benefits being pursued, and here are the costs we think we have under control.
Do I detect a volunteer?
Yeah, I knew you were going to say that.
I would love. I would, as I've heard said before, I would welcome suggested text, and I would welcome a suggested.
So I'm willing
document.
to collaborate, but I don't actually know any of the details here, and so I can't say anything. But I'm certainly willing to work on it.
Okay. Well, contact us offline. Last question.
Ron Bonica. One of the things that traditionally has made IP unicast forwarding, well, routing work so well, is that things that happen in the forwarding plane don't cause state to be created. Things that happen in the forwarding plane don't cause control state to be created. I think LISP may bend that rule a little bit, in that there are caches that are required that you need to be built, and when you have a cache, you have to worry about it being overrun, being attacked, all that sort of thing. Have you given thought to how you deal with the problems of caching?
I'm not really the right person to ask that question, but yes, we have, and Dino in particular has, because he's done all the implementation work. But there are, I mean, certainly at the IP layer, what you said is true. There aren't dependencies for unicast. But if you look at ARP, I mean, ARP by definition is state that's created on demand, and it is a cache.
Well,
so there is a precedent for that model.
It's a little bit different because you only ARP your neighbor. You don't do that much ARPing because you don't have that many neighbors. Whereas I think in LISP, you have to create state whenever you send a packet to a new destination that may be multiple hops away.
To a new destination site.
Yes.
Remember, the cache entries cover more than just individual prefix, individual /32s.
Well, that's a fairly unbounded number, isn't it, though? If this were globally deployed, there'd be lots and lots of destination sites.
There would be on the order of 300,000 today, assuming you don't do any aggregation. We believe that's that's clearly a manageable number in the global routing system today, and we believe that that number will be a lot smaller when you do reasonable aggregation of EIDs. So yes, we are aware that caching has a long and illustriously mixed history in routing forwarding state. A lot of that, we believe, was based on bad implementations trying to solve the wrong problem. This is a much more narrowly scoped problem that you need to cache, and the number of cache entries is much smaller, and they don't have to be requested nearly as often. Mm-hmm. So
Okay.
we think that it's doable. I mean, one of the reasons these are experimental RFC proposals is because there's a lot of experimentation to be done, and there's a lot of operational experience. We have a little bit. We have a lot more to gain.
One thing that might help is if we could shed some light on what elements of caching work well and which ones don't work well, and maybe explain away the bad experience that we already have with caching.
That's a good suggestion. One thing I will note is that the folks down at UCL in Belgium actually did do a study of kind of cache dynamics and prefix prevalence and how many things a typical site needs to actually contact. And the number is actually much smaller than you would expect. So the cache, according to their study, the cache sizes are actually going to be much smaller than even we expected them to be.
A security analysis would also be interesting because a cache is a good thing to attack.
Sure. All good suggestions. Please, I welcome the discussion on the IETF, the LISP IETF amendments. And that's it. Enjoy the break.